Welcome to EDU World Space.
Problem 7.59. We're told we have a spring that does not obey Hooke's law, but rather has an extra quadratic term in its force equation. These are the particular spring constants we have. And what we would like to do first is to get an expression for the potential energy in this spring with the initial condition, constant of integration, or whatever you like, that at zero compression or extension, the potential energy is zero. And then we imagine we have a 0.9 kilogram mass that's pulled 1 meter away from its 1 meters to the right of the equilibrium position, and then let go. And then we want to know what the velocity of that mass will be when its x position is half a meter. So, part A. Now we know that the force in a given direction of the partial derivative of the potential in that direction. And through the fundamental theorem of calculus, basically, this means that we can write the potential as this, its value at 0, minus the integral from 0 to x of what we'll call s, our constant of integration, or not constant, I'm sorry, a variable of integration, ds. We're told we want this to be 0. So this is the negative integral from 0 to x of negative alpha s minus beta s squared ds. This is equal to 1/2 alpha x squared, which you would expect because it does have the linear behavior of a spring that's then modified with the quadratic behavior. And then we have a 1/3 beta x cubed now in addition to that. So for part B, we want to use the conservation of energy. So it's let go from rest. So we only have an initial potential energy, and that will then be equal to the final potential energy, because the potential energy is 0 at x equals 0, and this is at x equals 1/2 meter, plus the kinetic energy, which is what contains the v that we're after. So we can just evaluate the expression we got in part A. Yes, and we'll find that this is 36 joules. This is 8.25 joules. And so we have 1/2 mv squared is equal to u initial minus u final So V is equal to 2 times this difference divided by the mass. And so this is 7.85 meters per second.